I kind of threw this presentation together at the last minute. One of the fun things about working on DALL-E 3 is you generally get like a chance to put a lot of imagery in presentations, but I didn't have a chance to do that, so I apologize. It's going to be kind of a boring slide deck, mostly just to help me guide my conversation. So yeah, I was just for DALL-E, I'm going to talk about kind of some of the design decisions we made for the project and like how they impacted what we ended up putting out there, and hopefully it can take 15 to 20 minutes, and after that we can just chat about any projects that I've worked on or I'm thinking about. So to start out things off, I want to talk about Tortoise real quick. So as Aleksa mentioned, it was like a text-to-speech system that used DALL-E's architecture. DALL-E 1, the original one, which is just an autoaggressive decoder hooked up to a VQ-VAE. This was like a fairly unique approach in the speech space at the time. Most people were trying to build text-to-speech systems that could like run on a device that were fast and kind of sacrifice quality for speed and accuracy of the synthesized voices. I kind of saw an opportunity here. Ironically, I was like mostly interested in building a system that could like do audiobook reading really well, because I listen to a lot of audiobooks. I have some like favorite narrators that I like to kind of hear read various books that they haven't actually read. And so I kind of tackled this as like a pet project while I was working at Google. It's also an opportunity to learn kind of the GPT architecture, VQVs, and diffusion. I knew a little bit about diffusion from previous work. I think looking back, one of the more novel things that I did in Tortoise was I used an almost entirely synthetic data set. I think about 90 to 95% of the data that I used, I had scraped audio from the internet, and then I had used Wave2Vec to transcribe the audio that I had fetched, and then trained a model on that transcribed audio. Like when I had done it at the time, it seemed obvious. It's like, okay, well, you want to train like a large language model essentially that does text to speech. You need a lot of data. You will need way more data than you actually have labels for. So how do you get it? You just go and like synthesize it. But I guess like looking back, this wasn't like a obvious thing in the industry at the time, and not something people were doing a whole lot. And I think that more than anything, this is like really what drove Tortoise to be as good as it was. It wasn't like I was a expert model designer or I was particularly smart. It's just that I had a lot of data and I was able to train a large model. I had a lot of data in a fairly large amount of compute, and I was able to train a large model that fit this data set that I built. So jumping forward, after I got hired at OpenAI, the first team I worked on was on the DALL-E team. I got hired right around the time that DALL-E 2 had been released, and they were spending up an effort to kind of make broad improvements on it. I list 5 things here that we were particularly interested in supporting. Human details like hands and faces were kind of poor in DALL-E 2. Couldn't do text at all. This actually wasn't as much a focus as I thought it should be. This is something I pushed more than anything, like text rendering. I think it's one of the determining features of DALL-E 3. Variable binding refers to like if you say an object is orange or red, or if you describe an object as a certain shape or something, or like where it is in the picture, that it actually appears in the picture with those attributes. Complex prompts would be like the ability to describe an image in a lot of detail and get all those details out. And then I think DALL-E 2 was particularly bad at like high resolution imagery. And so we wanted to kind of improve that. So the way I've structured this talk is I'm just going to go through all these weaknesses and talk about kind of how we addressed them. Starting with human details. So I saw this as a scaling issue. So human details in general, that like honestly like any kind of, so human details are weird. Like we as humans like look at images, we see immediately like there's 6 fingers on that hand. This is like a weird image. We can't deal with that. But I think we're less ready to see these same defects. If you look at like images of fish, maybe like a fish of some species should only have like 6 spines on the fins, and maybe DALL-E draws it with four spines. Like we don't really pick up on that, but it's the same kind of like coherence issue where DALL-E doesn't actually understand how the real world works. It just is like imitating something internally, and And sometimes it gets those things wrong, but sometimes like we as humans pick up things that we latch onto some things and other things not so much. Interesting anecdote here is one thing I was doing while I was building DALL-E 3 was I have two young daughters, and I was constantly using it to like do coloring pages that I do with them at nighttime for bedtime. And you really get a sense for like how good or bad a text image system is by like doing coloring pages, because you like have to pay attention to all the like, little details in the image, and you like start picking up like things like, oh, okay, this is horrible at like doing flowers or like certain types of textures and stuff like that. And this is like something I mentioned here, the object coherence is mostly a scale issue. I noticed as we were like scaling the models like this, I was doing these coloring pages like, okay, well, you know, like not only are hands getting better, but as I said, like brickwork is getting better, or the details on like let's say a fish or a dog, whether or not a dog's arms are in the proper locations was getting better and better over the time as we scaled the models. So like, it became clear to me over 6 months or so, kind of working on this problem, training a lot of models, that as you put more compute into these models and more data, and you make them larger, like these things like hands and faces, they just start naturally fixing themselves. So this gets at the real core of the problem. Like, how do you actually get more data? Because like clearly we fixed this. We can make all these models a lot better if we just can get more data. The problem is like DALL-E was already trained on most of the data like with really good text captions that we could gather from the internet. Like the real limiting factor here is like good images or images with very good text captions. We have ways internally to measure how good a text caption is for a given image. So I kind of took a inspiration from Tortoise for this. Sorry, I lost my presenter view. And I'll skip through these. And we started thinking about building a synthetic data set for image generation. Once again, it's like, it seems fairly obvious in retrospect, but I don't know that necessarily many people were thinking about this. I think Party, Google's DALL-E-like paper, mentioned a little bit about using synthetic captions, and I think that actually is the reason why Party and Imagen are actually as good as they are. I think Google's internally been doing this in some way or another on their data sets for a while, and they just never published about it. Yeah, we took a hack at it. In our first attempt, we built up a small image captioner that just does like a really basic caption. So like, given a picture of a cat playing with a toy mouse, it would output exactly that. It would describe the subject of an image, and sometimes like whatever the subject was doing, and nothing else. And we built a whole model stack over this and released it, and it actually showed up as the original Bing image creator, if any of you guys ever played with that. I think that in itself was a big success. I think it really kind of tackled this coherence problem, the human details problem. Like the Bing image creator that we came up with, it was a pretty good model. I think it was competitive in the journey at the time. It was around Midjourney 4, and definitely a leap forward over DALL-E 2. I think one regret I have is that we didn't have a chance to actually release that, as an internal product. But it is what it is. Oh, sure. What's up?
You're referring to the Bing image creator or which product? I lost you there for a second. When you said you didn't release it internally.
So we internally call this DALL-E 2.5. This came out as this is like a separate model. It's not DALL-E 3. It came out in the original Bing image creator, which is like released around February. Bing image creator hasn't since upgraded to DALL-E 3 a few weeks ago, as a lot of you probably know. Does that help?
Nice. Yes, thanks.
Yeah. So like this upgrade with this first attempt, it definitely improved like human details and coherence a lot, and we had some other fixes for high resolution images. I'll talk about that in a bit. But it didn't really fix like the tech. It did new text rendering. It didn't really fix the variable binding issues that we were seeing in a lot of our models, and it couldn't do complex prompts for obvious reasons. Like if you're training on a lot of captions that look like this, like a cat playing with a toy mouse, like that doesn't really leave a lot of room for describing like details about the room the cat's in, or the lighting, or the type of image that was taken, that sort of stuff. And so that's really what we really wanted to address for like our second attempt at this. And so this time around, we built another captioner that like viscerally describes images. I have to say, like as an aside, I was really surprised by how much details you can pull out of an image, which is like a very basic captioner, like we outlined in the DALL-E 3 paper. These models are able to store, or I don't know, just able to like, pull a surprising amount of details out of images that I didn't expect at all. Just be based on like my past experience with like classifier models or CNNs. They're very impressive, especially when you start scaling them. But so here's an example of like a caption like you might see from our descriptive captioner. It'll describe the type of image that it is, a picture. It'll describe colors in the image, like an orange cat or a gray rubber mouse. It'll describe the setting. It'll describe the lighting, and these are the like kind of details that start fixing the issues I was talking about before. Those are text, variable, binding, complex prompts. So yeah, so a very important thing is like it also describes things like color, position, text, and text is like the real key here. Like I think the reason DALL-E 3 can do text more than anything is the fact that anytime that our model was trained on an image that had text in it, the text was also in the caption. So like it learned this binding between like, okay, this text says hello world, and I see that in the image. Okay, I need to render that. Yeah. Sure. So.
Thanks. Can you please tell us more about that descriptive captioner? How was it built? Were you using some annotations from humans and then additional annotations from humans, or was it just from scraped data?
Have you seen the DALL-E 3 paper, by the way?
Yeah. So I was going to say the DALL-E 3 paper goes over this a little bit in a little more detail. I'm probably able to do with my voice, but I'll do my best. So we start with like a clip model. So we get a clip text encoder and image encoder. We tear out the image encoder, and we use that as like a reference for an autoregressive model. So you encode an image with a clip image encoder. You stick that on the context for an AR model, and then you have it decode a text description. You asked about the data sets that we use for this. It was mostly just images scraped from the internet. And then at the very end of the pipeline, after we train this captioner, we fine tune it on like a small data set of human annotated captions. So this is actually how we went from like the short descriptive captioner to the fully descriptive captioner. Is we like had the humans build like a data set of like examples of very long descriptive captions, and said, hey, like we want you to do this now. It's a fine tune. We want you to do this now instead of like the short ones. Does that make sense?
Sure. Thanks.
One thing that was really surprising to us is that it's all right. Was that training on like these ultra descriptive captions, what we're calling them internally, it markedly improves like eval scores on like otherwise equal models. So like we did a little bit of testing on this. We trained pure text to image models, equally sized for equally long on identical data sets, with the only difference being that like in some data sets, the images have the ground truth captions we got from the internet, and some data sets, the same images will have like this recaptioned descriptive captions. And we noticed that a model trained on these descriptive captions, not only does it like perform better on evaluations where you give it descriptive captions, but it also performs better on evaluations where you give it the ground truth captions. So it's like you've essentially built a better model across the board just by like training on cleaner data. I guess it's not like a groundbreaking discovery, but it is very cool to see that like synthetic data can improve things. Like in ML, there's always this concern that like when you use synthetic data, you're pushing your model out of distribution for real data, and that is true a lot of the time. So when you sample from a model out of distribution, it performs horribly, and so like one concern we have is like maybe our captioner would always describe certain images in certain ways, and so like if a human came along and tried to describe the same thing in a different way, the model would the text image model will no longer know how to generate the images correctly. But that didn't really seem to end up being the case. Yeah, so that was very surprising to us that the eval scores were improved so much. And the last thing I want to talk about here was like a big weakness in DALL-E 3 was the high resolution quality of the images. And we actually fixed this with by using the latent diffusion models that Stable Diffusion uses. I have to say, like, I was really blown away by how impressive the performance lift was by going with an LDM. Like, not only does it make the image quality a lot better, it also like improves the decoding performance by like a ton, because like DALL-E 2 was using a high resolution upsampler, and that was like a very expensive model. You have to do convolutions over 1K by 1K images, which I don't know how much experience you guys have with image generation, but that is a very expensive operation, especially at the model sizes we're working with. And yeah, with an LDM, you just kind of do diffusion over a latent space. It's much smaller and more compact. It just works very well. I think almost all diffusion models I train these days are LDMs, just because it works really well. DALL-E, it's worked well. Speech, music, anything that I really tried for. It's a very impressive paradigm. Downsides we've kind of encountered with this is, for some reason, LDMs have like this oversaturation issue. I think this is, I've seen a lot of people talk about this in the open source community as well. People have been trying to fix it with various like dynamic range clamps on the sampling process of the diffusion model, among other things. I think it's kind of goes on hand in hand with like the plasticky feel that many images have. I think what's happening is when you perform diffusion with this latent space, sometimes latents out of range, and the decoder doesn't know how to handle this properly, and it just ends up washing out the colors as a result. Another issue we deal with here is the high frequency details. So if you have like a very small text, if the model wants to render very small text, like I don't know, like a scan of a document or something, it has trouble doing that because it works in a certain resolution. It works at like 64 by 64 latents, and if the text isn't enclosed within that 64 by 64, it gets all washed out and blurry. I think the solution to that is to train a better latent space. Maybe future work. We'll see. That's actually all I have, but I'm happy to kind of field questions. So I guess let's start with you, Nicola.
Hi, James. Thanks for being here. Thanks, Aleksa, for having us. So I gave both versions a go, and I'd like to know if what I saw is a mere coincidence because of the very small sample and lack of any systematic testing. I was under the impression that version 2 got the semantics better in terms of what is happening, what is supposed to happen in the image, whereas version 3 kinda substituted that for style. Like, it was a more lavish image, a lot more detail, of course, prettier, and all that. The central object would still be there vaguely. Okay, it is still there, but as if like the emphasis was on the image looking good. It's not failing. Okay. But is it just my subjective impression, or is there more to it?
We have a mechanism that allows us to like tune the appeal of the images generated by the model, and it's very finicky and hard to get right. Like where to set that knob, because if you set it at some arbitrary value, like let's say 0.5, I'm just picking on numbers out of the air. Maybe that like gets you the ideal like balance between good-looking images, consistently good-looking images, and what I've been calling prompt fidelity or caption fidelity, which is whether the model follows the caption as opposed to making a really good-looking image. Maybe that works really well for pictures of cats or anime, but like it just falls flat for, I don't know, engineering drawings. And it's been very challenging to like figure out how to configure that knob, and we tweaked it quite a bit over the last few weeks, and we're still kind of figuring it out. I'd be curious as to know like what images you're actually running through it. I don't think in general I have found that DALL-E 2 is better at prompt following than DALL-E 3. We've done a lot of human evaluations that show that is absolutely the case. I think DALL-E 3 scores like 90% win rates over DALL-E 2 in this regime.
That was actually my next question. Like, how do you, like, we know we have the same issue with LLMs. Like, it's so hard to evaluate when the system becomes so complex and there is just so many things, so many domains you can tackle. Like, do you have any more systematic, automatic way of evaluating the models, or do you still mostly focus on human evals, which you have to do, obviously, but like, do you have any other way of benchmarks internal or whatnot?
This is a really disappointing part about ML in general. I think for me right now is no, I don't personally trust most evals because they can all be gamed, and they're all just very narrow. So no, like human evaluations are really I think our best human evaluation is the one that prompts a person with like a caption and image that says from like, either one model or model A or model B, and says like, if you were using a text image model, which one would you prefer the best? Because that is like actually captures exactly what we want. Someone using our tool and judging one after the other. So unfortunately,
how do you scale the human eval? Like, how many people do you usually have when you're doing evaluations? I didn't read the paper,
so
but
I think what you're getting at is how do I evaluate the model? How do we evaluate the models when we're training them? We use like ClipScore or FID, just like everyone else. The issue with both of those metrics with this particular model is that we're tuning it for human engagement and a few other aspects. Like we have some safety controls in place that during training, which like kind of fudge these numbers quite a bit. So like our FIDs are not competitive with the state-of-the-art FID, and so that's why we didn't release in the paper. But when you compare like a small DALL-E 3 with a large DALL-E 3 model, the FID scores do actually like go down. Like so between models of the same architecture or the same data set, you do see still some signal as to like improvement. Does that answer your question?
Yep, thanks. I think somebody raised a hand.
Yeah, I did. Thanks, James, for the presentation. I have a question, and I'm not sure if you have an authority to answer this because it comes to some architectural details. But you mentioned that text generation improved with only like the captions in images. For example, like your data set was way better captioned in terms of text and images. But was there any architectural changes in the model or not in terms of like, I've seen some research on how they've tried to improve this by treating like a certain characters as a different class in terms of text generation. Was there any attempts to do something in this area or not?
No, we didn't. I think so for text generation, I think you could make improvements by maybe like focusing on some subsets of the data more, or you can like. The answer is no. We didn't do any architectural modifications in that regard. The one big change we made between DALL-E 2 and DALL-E 3 is we adapted the T5 language model conditioning that adopted the T5 language model conditioning that Imogen described in their paper. We found that improved most metrics by quite a bit. German?
When do you think video generation will be done well? Do you think that coherent video generation requires scaling up orders of magnitude above image generation? Or do you think that there'll be architectural tricks that make it work at like a fairly similar scale to image gen?
That's a very good question. I feel like we're still not there with image generation. It's like what really bothers me about like trying to tackle this problem with video generation is like I'm proud of what we built with DALL-E 3, but like it's not like at my bar yet. Like it's not like I wouldn't step away and say this problem is solved. Let's go on to the next problem yet. And I kind of feel like we should get there first with images, but
makes sense.
Yeah. It also depends. Like with video generation, it's like how much computer are you willing to throw at the problem? Like when you want to generate a video. Like if you're willing to like spend the amount of compute we spend on DALL-E 3 for every single image, and do like do that 30 times for a single second of video, maybe we could have like a really compelling video generator right now. But I don't think anybody's willing to spend that. Like I think people are looking for like a really efficient architecture, right? Like where you actually reuse the fact that you know a lot of the subject of the image or something like that.
Yeah,
I'm not really sure what the appropriate way of doing that is just yet. I think that's probably a few years at least.
Makes sense.
We're waiting for NVIDIA to push out more GPUs, I guess.
Yeah. There's probably some really cool approach to video generation that is out there. Like I can't help but like think this is a representation problem. I think most video gen efforts right now, they focus on like frame by frame, and they're trying to get inner frame coherence. So like you generate a frame, you generate the next frame condition on the previous frame and text, you generate the next frame condition on the previous frame and text. Like you should be reusing some of the compute that you used to generate the first frame going forward, or you should at least have like a compressive latent space, like a compressive LDM, where like you do a diffusion process over, you know, a long series of latents, and you use those to decode like those latents into a video with a single pass with like a smaller network, similar to what Stable Diffusion or DALL-E 3 is doing. But that's sort of like weird variable bitrate compression. We don't really have good algorithms for doing that yet that I know of.
That makes sense. Quick question on the counting, like. Does the current DALL-E 3 model, like, did you guys solve it? Because maybe I'm a bit out of sync, but like, do you still have issues with counting, like for example, rendering fingers or stuff like that? I guess with fingers you're better now, right?
Oh, fingers, yeah, fingers it has down. Counting and my pet peeve problem is the left-right chirality. Like it does not know left from right, and this is actually like an artifact of the fact that our captioner was trained on CLIP image embeddings, and CLIP doesn't know these things. It doesn't know counting above a certain number, and it doesn't know left from right. It drives me crazy. Definitely something I want to fix.
How do you think about, like, more generally, like how do you think, how are you planning on handling the let's call it reasoning aspect, like just counting and understanding the relationship? Like what's your thinking on that one?
I think we need more closer integration with the language model space. I'm pretty bearish on like an image generation model developing any kind of reasoning skills, just based on the gap of reasoning abilities between GPU 3.5 and GPU 4, both of which are like orders of magnitude larger than DALL-E 3. Means like we first of all have to train a DALL-E 3 model at like 3.5 or 4 scale to even like have a possibility of getting these reasoning skills. But more likely, like images are less efficient at like conveying reasoning skills to machine learning models, and so likely you need to be like an order of magnitude above GPT-4 to like get this type of reasoning ability. So I think the best approach is to borrow the reasoning from language models and like have them do all the reasoning and then shuttle it off to the image generation. Does that make sense?
Definitely. I mean, we've seen that with vision language models, with Flamingo and other models. Like you just use the pre-trained LLM as the core, and then you learn the cross attention or whatever you're doing with the vision encoder.
Definitely, like we're trying our best to kind of marry our language models with DALL-E 3, like in the best way we could, like by training them separately. I think in the distant future, we'll obviously want to train these things all together, like an image generator that's also a language generator and it's also an audio generator, multimodal models. Can't really speak to that though.
Yeah, I guess something like that from DeepMind along those lines. I mean, the ideas are fairly widely spread out, right? Like many things also happen in the open source community, as you mentioned, the LDM. Like it really boils down to having like I think we don't talk enough about the infrastructure and the engineering, and like it's mostly if you have a ton of data that's high quality, if you have a ton of compute, you can do magic. Like, and I think that's still underappreciated.
Yep, I totally agree. On both points, like yeah, it's all about data and compute, but also it's very much an engineering problem.
100%. Did anyone have any question? I mean, I know from your blog post that like that was part of the reason why you built all of these rigs back in the day. You were very bullish on just like you understood fairly like, well, was it early? I don't know. When did you start building the tortoise, the TTS? Was that in 20?
Started in early 2021.
2021. Okay,
a little over a year. It's a little bit after the original DALL-E paper came out. Actually, it was very inspirational to me. It was like time flies so much in this space, but like DALL-E 1 was fucking incredible at the time. I couldn't believe that these models could do what they could at that time when that paper came out.
100%. Like some of those work just push the Overton window, and then after that it's just okay. Now we know we can do this. Now and then you have like the whole community just like doing the gradient the distributed gradient descent, and solving like tackling one problem after another.
Jamie
100%
asked a question here about prompting DALL-E 3 in non-English languages. I am a native English speaker, and I do not speak other languages, so I'm not the expert here, but my recommendation would be to tell ChatGPT in your language to prompt DALL-E 3 and like translate it to English. I'm pretty sure that will actually work pretty well. But I will also say that DALL-E data actually had non-English in it. So like the model itself does understand other languages. It just doesn't understand it well. It's like, I think English is like 80% or something like that, the data set. So you're gonna get your best results there. I guess that kind of sucks for text rendering. I'll be honest, I didn't even consider this, but yeah, I guess you probably won't be able to get DALL-E 3 to render text in your native language. It kind of sucks. Well, don't think about it.
I think it struggles even in English a bit. Like I think I rendered the Epiphany and I got some, instead of H, I got like an additional vertical bar or something. But like it's definitely way better than it was, no doubt.
Yeah. We're like, we trained a lot of different model sizes, and like DALL-E 3 was the largest one we trained, and also the first model where it was like starting to consistently get text, like in most images. And so I think we need like another, order of magnitude, or at least 2x in the scale to like pretty consistently get the images or the text right. It's a hard problem. Like if you think about how many ways you can write any given text, it's pretty incredible. Like some of my favorite images that I've done with DALL-E is like having it write text in like rock formations or in clouds, and it does a really good job at that. But like that's really hard to do. It's very impressive.
There's some questions in the chat. Do you maybe want to ask it yourself, or we can read it? Shubod, sorry if I'm butchering your name.
Sure. I can read it.
Yeah, sure.
So when DALL-E 3 is prompted to generate realistic images, it seems like you're easier to figure out it is actually generated by AI when compared to DALL-E 2. I would agree with that. I think a lot of that is well, I think it's two things. I think it's the latent diffusion model that we used. That decoder has like this weird, like plasticky feeling to it that we haven't really been able to kind of work around. The other thing to it is we have this like this model that pushes DALL-E 3 to produce like images that have like an artistic style that humans find engaging. And I think that pushes the model away from photorealism sometimes. So it's probably the two things you're running into. Definitely something we'll be improving over the coming months and years. Yeah, so we definitely want to do photorealism. It's like high on the chopping block right now. Yeah.
Nice. Let's take this one maybe. This second portion of this big question. Can you shed some light on how you're planning on detecting the AI-generated images? That's come from Raphael von Eigendorf.
I'm trying to find it.
It's just above Sherman Chen.
Oh, there it is. Okay. I'm not an expert in this field. I know at DALL-E 3, someone on my team built like a watermarking method that uses a technique that was published a few months ago. You can like you can distill watermarks into the diffusion process, which humans can't see, and yeah, that seems to work pretty well. But like actually detecting whether or not an image was generated by AI generators that didn't have like this technique applied to it, I think right now it's not too hard to build like an AI-based discriminator that does this. But I think long term that's not going to fly. I think these models are going to surpass any discriminator that you can build. We're just going to have to figure out how to work around that as a society.
Yep, 100% agree. Without some cryptographic signature built in, but like then again, you can easily, I don't know, it's easy to build a network that's going to input such an image and just like remove such a signature.
There's a question here from Sherman about crowdsourced efforts from the open source community.
Sorry, let me just read it out because for people watching later, if we publish the video, are there any experiments, crowdsourced efforts you'd find helpful to see done by the open source community?
Yeah, I'm definitely a big fan of Stable Diffusion and what they've done. my company has placed itself as a role of, or in the role of like developing AI safely. And I agree with a lot of the decisions that are being made, but I think if I was at the helm, I'd be a bit more liberal in terms of what I'd be willing to release. And I'm glad that Stable Diffusion put something out there that the community can work on and build on top of. I think everyone at OpenAI was like really inspired by the adoption that Stable Diffusion got. One project in particular that's very interesting is ControlNet. I think it's very, very cool application of LoRa to like make Stable Diffusion do all kinds of interesting things. Something we really like to build into our products in the future. I don't think there's a lot of light at the end of the tunnel in terms of like being able to open source something like DALL-E 3. There's a lot of concern over some of the images it can generate. Like as an example, it can do like nudity and stuff, or hate imagery, which is something that DALL-E 2 was like not able to do as well. This is largely because we like expanded our data set. We trained on more images, and some images contain nudity because like even the best nudity detector doesn't get rid of all of them. And these models are like, intelligent enough to like see 4 images of penises, and I can draw a really good penis at that point. And so like I just don't really see a way forward on open sourcing. This is something kind of we chased internally as the team. Like we really wanted to open source DALL-E 3, but there's just a lot of internal pushback, and I don't see it happening. In terms of like what the open source community can do, just keep working on Stable Diffusion. Like I think from folks I talk to externally, like at Facebook and Google, and internally, a lot of these projects are followed. We use them to improve our own models. We contribute where we can. Something I would love to get back into in the future too, to the best of my ability. Let's see. You want to pick the questions, Aleksa?
Yeah, I had a question. Like, I mean, I know this is more of a corporate question that like, and it's more general than OpenAI. Like, why is it a problem to just release a model that can produce nudity? Like, what's wrong with having a model that can produce nudity? Like,
yeah, you're asking the wrong person. I know,
like,
I don't care. Yeah. Good answer for you. Like, okay, I'm sorry, I can't answer that for you. It's because a model that can produce nudity and a model that can produce people's faces, you can combine the two. Like, I can make deepfake porn of anybody, and I think that is kind of a problem. Until we as a society kind of figure out, like, okay, images aren't real, and they can't be used in court. They can't be used to blackmail somebody, et cetera, et cetera, et cetera, right?
That's true, but it also seems that the open source models will get there eventually. Like we see that like Stable Diffusion is not that much behind Midjourney or DALL-E 3 or like, so in that sense, I don't know. It's a weird discussion that we're having as a society. I agree.
I like that. I see OpenAI's role. What we're doing is like exploring this like dark cave of like what happens when you scale the shit out of models. I'm not sure I'm comfortable like releasing models that make perfectly photorealistic images or perfectly deepfake someone's voices to the general public to just like go out and like do whatever you want with, because I think that like society needs like maybe 5 years at least to get their minds around it. Like there's some amount of time that we need to like just like slowly deploy these features and let people get comfortable with them. And I like that the pace that open source community is on right now in this regard. I have no doubt that within like a year or two there will be a DALL-E 3 equivalent on the open source table.
Yeah, and somebody who has enough money can probably already generate a fairly dangerous deepfake. Like, I mean, of course, we can debate it, but
no doubt about that.
Yeah, I mean, maybe going a bit from the topic of DALL-E 3 a bit more generally. I know a lot of people here in the chat are probably super curious. Like, again, your story is inspiring, and like, what would be your advice for somebody who's maybe younger, who is aspiring to land a job at OpenAI? Like, what would be your tips, something that's unconventional knowledge, maybe in your opinion, that's probably the most valuable?
OpenAI is quite unique. Well, it's not even unique. It's a small company that really values people who have direct demonstrable experience in ML and passion. Most of the folks I work with are PhDs, but there are a small handful of people who are like myself who kind of just had really cool projects, and that is essentially why they got hired. And so trying to find something you're interested in the space, doing a really kick-ass job, and publishing some interesting results, that'd be the way to get in if you're not willing to get a PhD. And I don't blame you for not getting a PhD.
100%. 100%. I mean, it's probably worth repeating that basically because of Tortoise to TTS and your work there, and you built your servers, you trained the whole thing, you combined a couple of interesting previous, if I remember correctly, you literally found inspiration in the DALL-E paper with the diffusion models, and you combined all that together, built a cool project, people noticed you, and that's it. It was a single project. It's not an easy, I'm not saying it's an easy thing to do a single project, but such a thing can already give you such a big, potentially bigger credential than you going through the PhD route that so many people go through, right? So it takes I don't know, 5 years, as opposed to if you were really obsessed with something and in a span of a year you built it, you could have a higher chance. Plus, because it's not standard, so it's in a way it's easier, but requires higher agency, I guess, or level of being comfortable with open-endedness and just building something on your own, and that's not something everybody can do. So I understand why not everybody's doing it.
Yep, 100%. I will say the other angle to this is I wouldn't recommend anybody taking on a project with the sole goal of getting hired at OpenAI or Facebook. Do what you like first and foremost. Get a job that pays the bills, do something on the side, and use that work your way into the industry. I wouldn't do something like Tortoise with the sole goal of getting hired. I didn't build Tortoise because I wanted to get hired at OpenAI. That just kind of happened on the side. I built it because I genuinely enjoy working in this field.
But even if you let me push back there. Even if your goal was, because some people might have that goal, maybe somebody just wants to build a project because they want to land a job at company X, whatever. But even if you don't get into that company, you're gonna learn a ton, and you will get noticed in the space. So you're going to get offers, no matter what your incentive for building that project was. But ultimately, if you're having more fun, that's obviously better than not having fun.
No, you're right. You're right. Yeah, building the experience will help you and pass the interviews, right? If nothing else, even if you have nothing on your resume, the project failed and there's nothing interesting to publish about, the fact that you went out and trained an AR model, learned how to build a sampler on that AR model, figured out what works and what doesn't work, all that stuff is going to translate directly into your interviews. So 100%. I do agree on that.
Maybe one question on the hardware side for me. By the way, guys, if you have any questions, raise the hand, please, because I'm hijacking the meeting as usually. James, if you have any, do you care about the whole hardware space? Because I assume you do, because you're bullish on compute. What do you think about the future of compute over the next years? With we have now this whole competition between AMD and NVIDIA and GraphCore and all these new players popping up. Where do you think the whole chip industry is heading at the moment?
More of it. I'm not that deep into it. Yeah, are you asking who do I think is going to come out ahead? I think NVIDIA is going to come out ahead, unfortunately. I don't like them as a company, but no one else is really pushing open source, and I really do feel that grassroots approach. Get an accelerator in everybody's computer, and everyone can go out and try these things. They can do inference on stable diffusion. They can tinker around with it and do a LoRa fine tune or whatever, but they're doing it on your hardware, and they're learning CUDA essentially implicitly through PyTorch or whatever. That makes a big difference. If you told me to go out and build an AR model on a GraphCore processor, that would take me several months to kind of get up to speed, and that's a big impediment in the industry, right? Even TPUs are kind of hard to get your head around. They take a lot of training.
I 100% agree. But then there's the work from OpenAI, the Triton. Is that how you pronounce it? I think that doesn't abstract away the whole. You don't care whether it's CUDA now or is it ROCm, however you pronounce the AMD's tech stack. What do you think about Triton?
Actually, funnily enough, I just wrote my first Triton kernel yesterday. I feel embarrassed saying it, but we have an entire team at OpenAI who's obviously we built Triton, and we have a whole team that's building Triton kernels for us. So I didn't have any reason to learn the language until yesterday. I was just doing some random side project, and I had like a double for loop through a matrix. It was taking like a second per training step. I'm like, okay, it's time to do this in Triton. And sure enough, it's like a microsecond or something. What was it? Your question is like, what about Triton and how it will affect IPUs? I couldn't really tell you that. I don't actually know how well Triton is supported on other accelerators. Do you? Like, does it just work on like GPUs? Does it work on GraphCore like really well?
I think a couple of months ago, I saw the commit that introduced the EuroCamp support in Triton. That was a big news. Maybe a month and a half ago or something. So like that may be a bit more like optimistic about AMD.
But once again, like I still keep coming back to like this issue. Like even if Triton professes to kind of fix this problem, are you as like a small AI startup who's only got like $10 million in funding, are you really going to go drop $5 million on a GraphCore processors, just like hoping that this is all just going to work out and like the promises of Triton are going to come through? Or are you just going to buy the NVIDIA stuff like everyone else because everyone's familiar with NVIDIA and knows it works?
100% sure. For the startup like part of the spectrum, I 100% agree. But like maybe bigger companies can get special deals, and so there are incentives that those companies, chip companies, can do to kind of penetrate the market and then slowly trickle down to the consumers.
I hope so. I hope so. I really hope to see more people playing the open source small consumer market.
Yeah, I'm honestly surprised that we didn't see more ASIC companies popping up. I saw one from Max Google folks who were literally instrumental in building the TPU stack and everything, and I saw they started their own startup. So like, I'm surprised nobody built a dedicated simple engine that just runs transformers and that's it. And I think they went ahead to start precisely that, because like at this point it seems like a couple of these like operations spawn out and a couple of these architectures seem to be winning. Like there is obviously every now and then something happens. Like the recent, what was the name of the RedNet paper from Microsoft? I don't know if you saw that one.
I didn't.
They basically showed promising results for sub 6 billion parameters compared to transformers, like across various metrics, and they were training it also on AMD compute. That was also fun for me to see. So like 512 AMD chips or something. I can send you the link.
Yeah, please. I'm kind of curious. Retentive networks?
Yep, I think that's the name. RedNet or Retentive networks.
I'll check that out.
Awesome. Cool. Guys, you have any other questions? If not, I'm going to think maybe I have something else to ask.
No, I can't speak to that. Good try.
Okay, I don't even know what's the hint about. I didn't see the latest Twitter news. Okay. Here is one more question. Will a master's or PhD in mathematics be more valuable than an equivalent qualification in ML data science from the perspective of getting into ML jobs? So mathematics PhD versus equivalent qualification in ML.
It's so far from my path that it's hard for me to like really make it a call here. I do a lot of interviews for OpenAI, so I do get to like interview a lot of people who are way smarter than me, PhDs in math and such. And I will say that like the folks who really impress me are the ones who have like applied knowledge, regardless of their field of study. And so like if they can program well, for example, like a PhD in math that like knows NumPy like the back of their hand is an impressive candidate, regardless of whether they have any direct experience in data science. I think so. So is synthetic data the way to future models? I'm really bullish on synthetic data. I think it's like the solution to all our problems. If you consider all our problems like getting more compute and getting more data, like so half the problem is getting more data. Where do you get it from? You generate it. No problem.
Talking about the devil, like on the flip side, like some of these, like the text being generated by maybe lower quality models and being spread out across the internet. Like, what do you think about that whole concern of what's the name? Like, no, I forgot what's the name of the theory where eventually we'll just have a ton of low quality data or whatnot. I
think this is the key here is like you want pairs. You want synthetic data and like the real data that was derived from. So like this whole like speech, I took like with tortoise, I took speech and I transcribed it and then into text and generate that. That's like my synthetic data pipeline. For DALL-E, it's like a real image and a caption. I think like having like some ground truth or some grounding, and then like the synthetic data is really the key here. But like you can imagine that like now we have this captioner, we could go take all the videos on the internet and go caption all those videos, recaption all those videos, like build stories out of them, for example. I don't know if you play with that feature in GPV, but it's like really good at if you give it 30 video frames and ask it what happened in this video, it can like give you a whole narrative. Like these types of things, I think are very interesting way of like gathering data, and you don't necessarily have this downside that you're talking about if you also train on the images or the audio, because you have like this access to ground truth where you can't degrade into like a mean.
Exactly. And then maybe one more question, we can slowly wrap it up. Tyler, TPUs are really hard to use. You have to modify your entire code to use them. GPUs are much easier. Usually they require only 1 or 2 lines of code to use. Okay, that's just more of a comment. And then, but won't TPU pay off in terms of cost and speed? What's your take on TPU, if you have any?
I'm really worried that like TPU, that Google's new TPU architecture is like really good, and it's gonna like leapfrog NVIDIA, and the only people who have access to it are DeepMind. I don't know. Maybe you're the person to talk to, Aleksa. How are TPUs, right? Were they the bomb?
No comment. No, I don't know. Like there is one thing. Like if you have, I don't know, if you have some entrepreneurial ambition and later you want to start your own company, like the thing is, it's easier to find a person who knows how to use a GPU than a TPU, right? Like even, I mean, it's not that steep of a curve, but still like, and also like the company that builds it definitely has advantage because they can drive the progress forward. They can have internal like optimizations that you cannot have as a consumer. So from that standpoint, I don't know. That's the bad part. But then it's fairly impressive. Like when it comes to just raw computing power and all of that, that's definitely impressive. And it's crazy that one company managed to pull it off and just like keep it to itself and just expose it through the cloud or whatnot. So that's kind of crazy.
Yeah. They saw the light at the end of the tunnel, though, man. They invested over many years. I think, and Google deserves what it got with TPUs, frankly.
Awesome, James. This was huge pleasure to have you in the I guess server. Sorry for not being clear enough about the presentation.
Oh, yeah.
Basically, the story was like I just met with James 5 minutes before this call, and he was like, "Oh, we need presentation slides." And then
I thought it was gonna be an interview.
and then he made the slides in like 15 minutes. So that was cool. But I think the questions and your answers were super valuable. I'm sure people took a lot from it because I know I did. So yeah, I think we can slowly wrap it up.